Module 4, Lesson 19, Substituting to Evaluate Addition and Subtraction Expressions. Take a look at the learning targets here. And I know these are looking really familiar. We are going to continue to represent real-life situations in mathematical expressions. And we are going to do some experimenting today. We are actually going to create some input-output charts and see what happens. So as some values change, we're going to work from specific to general situations. So we're going to have a chart with a very specific set of information, and then we're going to try and express that as an algebraic expression. And then we're going to look and say, well, what if this value is this? How would it work? All right, I can statements. I can represent real-life situations by writing expressions with variables and the operations of addition and subtraction, so similar to the last lesson. I can use substitution to evaluate an expression for a given value of a variable. And then we are going to expand this into the use of input-output tables. In the last lesson, we were really looking at single instances. We'd have an algebraic expression, but we would be given one value that we would substitute in. Now we're going to be working with multiple values that we will input and see what happens. All right, so opening activity here. My older sister is exactly 2 years older than I am. Sharing a birthday is both fun and annoying. Every year on our birthday, we have a party, which is fun, but she always brags that she is 2 years older than I am, which is annoying. Shown below is a table of our ages, starting when I was born. So whenever I get a table, I like to take a look at it and see what information do I actually have here. And I see that we've got the narrator's age in number of years, and the narrator's sister's age in the number of years. And I am observing here that the narrator's sister is 2 years older, which matches we were told in the story. So now we're going to look at this table, and we are going to observe for some patterns. And it would be great if you had someone you could talk to for this, but if you don't, understandable. But at the very least, take a moment, look this over, and think to yourself, what do I see? One of the first things that frequently jumps out at students is we have an increasing by 1 as we go down the columns. As we go across the columns, I am observing that the column is always 2 greater than the first column. And looking at it the other direction, I am observing that the first column is always 2 less of the second column. So it's important when we look at these tables that we look carefully. There are a lot of relationships happening within these tables. And of course, what we're going to have to decide is which of these patterns are actually useful. Just because we observe a pattern doesn't mean it is useful in what we are trying to accomplish right now. Probably the most useful at this point is that the sister's age is always 2 years more than the narrator's age. This relationship this way doesn't have to stay this way. It doesn't have to grow by 1s. I could all of a sudden jump to an age of 15 if I wanted to. So this pattern of increasing by 1 is not locked in place. The relationship in the table is between the ages. And here we have an example. On the day I turned 8 years old, how old was my sister? So they are asking a question here that is not on the table. They're asking us to jump out of sequence. They didn't ask for the age at 5. They said, hey, let's go to 8. Now the relationship runs from column to column. We have the narrator's age is 8, and we know that the sister is always 2 years older. So we should be able to figure out that the sister was 10 years old. Now the question is, what was our thought process to get to that conclusion? How do we know? Well, the sister's age is always 2 years more than my age. Always. And by my age, we mean our narrator. So we would take whatever the narrator's age is and we would add 2. So, on the day the narrator turns 16 years old, how old was the sister? Well, once again, we're going out of sequence here. So we have 16 years old, and we know that the relationship is 2 greater. It is 18. Now, some students at this point may be trying to do some of the cool stuff we did with ratio tables. They might say, well, I multiplied by 4, so I multiply by 4. But you should notice here that this is not a multiplicative relationship. This table is built on an additive relationship from column to column. So no, I can't quadruple the 4 and get 16, and quadruple the 6 and get 24. Are the 2 ages 2 years apart in that situation? The answer is no, they are not. So it's important as we recognize relationships within the table to recognize, do we have an additive relationship? Do we have a multiplicative relationship? In this case, we've established it's an additive relationship. So the older sister would be 18 years old. And how do we know? Well, the sister's age is always 2 years more than the narrator's age. We're going to add 2. So do we actually have to extend the table? Do I actually have to write out 5, 7, 6, 8, 7, 9? Do we actually need to write all of that out? Do we have to keep adding rows to the table to answer these questions? Well, hopefully your brain is screaming at you, no, I don't need to do that. Whatever the narrator's age is, add 2. So we could say that the narrator lives to be 576. How old is the sister? She's 2 years older. So, different question. What if you don't know how old the narrator is? So let's use a variable for the narrator's age. And they're going to clearly state here that they are going to use y. Let y equal my age in years. Notice that they have given a very specific assignment to this variable. So is there an expression that can be written to describe how old my sister is? So we have looked at specific situations working with specific numbers, and we're now going to move to an algebraic expression that gives us a general description of the situation. Well, we know that the sister is always 2 years older. And if y is going to be the age of the narrator, we would increase that by 2. So an algebraic expression would be the sister is y plus 2 years old. And if we were to add this to the table, we would have the age in years as y, and the sister is y plus 2. We now have an algebraic expression to describe the relationship within the table. I can now pick any age that I want to for the age of the narrator, substitute it in, and find the sister's age. Computer programmers do stuff like this all the time. They try to think in general situations and develop algebraic expressions. And then when you sit down at the computer, a little box pops up that says, how old are you? And then it performs the calculation and says the sister's age is. So those of you interested in computer programming, this is a big thing. All right, so on the day I turned 8 years old, how old was my sister? Well, my age was y, and my sister's age is y plus 2. So my age is 8, and the sister's age is 10. And how do I know? Because we take the age and we add 2. Now we're going to look at it in a slightly different way. how old was I when my sister was 6 years old? So now they're giving me information about the sister and asking me to figure out what's happening with the narrator. So instead of running from left to right across the table, we are now turned around and going from right to left. So we need to think about what's happening here. Well, when my sister was 6 years old, I was 4 years old. And when my sister was 15, I was 13. Now, of course, the question is, how do we know that? How do we know that that's the case? Well, the narrator is always 2 years younger. The narrator's age is always 2 less than the sister's age. So you should be thinking to yourself, hey, how can I represent that algebraically? How can I write an expression for this? So look at the table in example 2. If you know my sister's age, how can you determine my age? Well, hopefully your brain is saying to you, take the sister's age and subtract 2. Well, wait a minute. Take the sister's age and subtract 2. So if we use the variable g for the sister's age, what expression would we use to describe the narrator's age? Well, hopefully your brain is screaming at you. Whatever the sister's age is, subtract 2. And I have already added that in the bottom row of the table. All right, so with partner, take a moment and calculate how old the narrator was when the sister was 22, 23, and 24 years old. Now, in an ideal situation, you'd be able to add this information down to your table, onto the bottom of your table here. I didn't leave myself quite enough room here. So I am going to just quickly construct myself a little table here. And I've got the sister and the narrator. And I know that the sister is going to be the variable g, and the narrator is g minus 2. And now I can substitute some values in here, 22, 23, and 24. And 22 minus 2 is 20. And 23 minus 2 is 21. And 24 minus 2 is 22. And of course, we could pick any value we wanted to for the sister, and we could find the narrator's age. All right, so Noah and Carter are collecting box tops for their school. They each bring in 1 box top per day. That sounds like a rate there. 1 box top per day, starting on the first day of school. However, Carter had a head start because his aunt sent him 15 box tops before school began. Now, Noah's grandma saved 10 box tops, and Noah added those in on his first day. So let's stop and think about this. How would we complete this table? How are we going to fill this out? Well, on the first day, they've got that Noah has 11 box tops. Now, we should stop and ask ourselves, where did Noah get 11 box tops from? Because it says he brought 1 box top per day. Now, hopefully your brain also says, but wait a minute. He brought in the box tops that Grandma gave to him. So on the first day, he brought a box top, plus he already had 10. So on the first day, he brought 11. And Carter brought 16 because the aunt came through with 15 box tops plus the one that he brought. So on the first day, Noah's going to bring 11 and Carter's going to bring 16. Now, on day 2, how many is each of the boys going to bring? And I need to point out right here, very carefully, we are talking about the total number of box tops each boy brought to school. So we're not talking about how many did they bring each day, we're talking about their total numbers. So on the first day, Noah brought 11. On the second day, he's going to bring 1 more, so he now has brought 12. And on the third day, he's going to bring another one, so he has now brought 13. And on the fourth day, he brings another one, he has now brought 14. And on the fifth day, he brings another one, 15 box tops. Carter started with 16, and each day he brings one more. 17, 18, 19, and 20. So lots to think about as you look at these tables. Make sure that you are reading and understanding what is happening here. All right. And now we're going to take and create an algebraic expression to represent what is happening here. We have looked in very specific situations, day 1, 2, 3, 4, and 5, but now we want to have D be the number of days. And we want to work from D and figure out how many box tops each boy has brought. So we need to think about this for a second here. How can we represent this with an expression? Well, we know he got a head start from his grandma, and he had 10 of them. But then we know that he's going to bring one each day. Now, what would be the easiest way to figure out how many he brought each day? Well, if there's one day he brought one, if there's 2 days he brought 2, if there's 3 days he brought 3, and if there's 15 days he brought 15. So how am I working from the days to the number of box tops he has brought? Well, that's multiplication. I am taking the number of days and multiplying by 1 because he brings 1 each day. So he's got the 10 that he originally brought plus the number of days. So how many days plus the 10 box tops? And I gave you kind of an example of how I thought my way through this. So how would you do this for Carter? I kind of showed you for Noah. Think your way through. What would you put for Carter? We have D for the number of days. Well, he started out with 15 from his aunt, and he's going to bring 1 for every day, 15 plus D. And we can go ahead and add those expressions to the table. D and days plus 10, days plus 15. Can I change the order? Could I do 10 plus D? Of course I could. Commutative property of addition says that I can change the order of the add-ins. All right, on day 10 of school, how many box tops will Noah have brought to school? Well, I know that Noah is days plus 10, and I know that Carter is days plus 15. So if they are saying 10 days, he brought 20. I took the number of days, and I increased it by 10. On day 10, Noah would have brought 20 box tops. Well, how many would Carter have brought? Well, number of days is 10. Add that to the 15. And I've got 25. Now, interestingly, because, love the patterns here, Carter has always brought 5 more. Now, you should be able to explain why Carter's number is always 5 greater. And hopefully your brain screams at you because he had a 5 box top head start, and they have brought the same amount every day. All right, different situation here. Each week the primary school recycles 200 pounds of paper. The intermediate school also recycles the same amount, but had another 300 pounds left over from summer school. The intermediate school custodian added this 300 pounds to the first recycle week. And I am pretty sure that I did not change this table. So I'll need to fix that. Well, that's okay. I can handle that. Let's see, it says, each week the primary school recycles 200 pounds. The intermediate school also recycles 200 pounds every week, but they had another 300 pounds left over from summer, so their first week was a 500. Now it says number the weeks. and record the amount of paper recycled by both schools. So I've got my weeks here, 1, 2, 3, 4, and 5. I have figured out my starting point for each one, and it is going to increase by how much? Well, 200 pounds each week. So I'm going to add 200 pounds. Excellent. So now the question becomes, what about after, say, 10 weeks? Where would we be at? Well, I can see that on this table, I'm taking the number of weeks and multiplying by 200. So the primary school is, and I'm going to use a W here, and I've got the weeks times 200, which I could also write as 200W. And over here I've got the weeks times 200, and I am adding 300 because they had that 300-pound head start. So I would find that after 10 weeks, the primary school has recycled 2,000 pounds, and the intermediate school has recycled 2,300 pounds. Once again, looking at the relationships here to establish an algebraic expression. So if the trend continues, what will be the total amount collected for each school on week 10? Well, just walked you through that. I forgot to put the animation in. So I walked you through on the last slide. So I've already done this problem for you, given you an explanation. All right, Shelley and Kristen share a birthday, but Shelley is 5 years older. So let's make a table showing their ages every year, beginning when Kristen was born. So I will have Kristen, and I will have Shelley. And Shelley is 5 years older, so when Kristen was born, Shelley is 5 years older. And when Kristen is 1, Shelley is 5 years older. And when Kristen is 2, Shelley is 7 years older. 5 years older. When Kristen is 3, Shelley is 5 years older, which is 8. And when Kristen is 15, Shelley is 5 years older, which is 20. Notice that I skipped in there. That's okay. I'm playing with the numbers. I'm seeing what's happened. So if Kristen is 16 years old, how old is Shelley? Well, Kristen is 16, and Shelley is 5 years older, so she'd be 21. Now, how do I know? Because it says Shelley is 5 years older, so I take whatever Kristen is, and I add 5 to it. Now, of course, the question is, how could we express this algebraically? So if Kristen is K years old, we're going to replace Kristen with a K. What expression would I write to represent how old Shelley is? Well, I take whatever Kristen is, and I'm adding 5. So Shelley is Kristen plus 5. Now we can turn it around. What if we go the other direction? What if I work from Shelley's age? How do I find Kristen's age? Well, to go from left to right, we were adding 5. So what if we go from right to left? What is the inverse operation here? What is the opposite operation of adding 5? Subtracting 5. So I'm going to take Shelley's age and subtract 5. All right, so why were we able to write these expressions? Why were we able to come up with this information right here? Well, it is important that we recognize that we had a fixed relationship. They were always 5 years apart. That's a fixed relationship. It's not changing. Shelley is always 5 years older than Kristen. Kristen is always 5 years younger than Shelley. We can identify that relationship. We can look at a chart of information and recognize that this relationship is not changing. And then we can write an expression to describe that relationship. We can actually say, here is what is happening. Now, what is important to remember about labeling columns in a table? What needs to be done when you label these columns? You know, it's really important that the label should be complete. We have some type of units. What are we counting? So when somebody looks at our table, they can understand exactly what we mean. We know that we're measuring Kristen's age in years, not days or weeks or minutes or seconds. We need to be specific. Communication. And how are addition and subtraction expressions related to one another? They are inverses. They're opposites of each other, and we looked at that right at the end. Kristen plus 5 and Shelley minus 5. So, and I use the word undoes here. If we added 5, how do we undo adding 5? We subtract 5. By the way, that should look really familiar, clear back at the beginning of Module 4, as we worked on these properties of operations and the relationship between the operations. If we subtract 5, we can add 5 and we're right back where we started. If we add 5, we can subtract 5. We're right back where we started. This is what it means when they undo each other. All right, so hopefully at this point, you can represent some real-life situations by writing expressions with variables and the operations of addition and subtraction. Hopefully you can substitute a number in and see what happens. So evaluate an expression using substitution. And hopefully you could generate an input-output table to help you evaluate expressions. And you'll notice that as we use the input-output tables, we were also figuring out what are the expressions. So we would look at a set of data and identify the relationship. All right, learning targets here. We did touch briefly on the relationship between operations at the end there as we talked about addition and subtraction. Certainly representing real-life situations using mathematical expressions. We did a tiny bit of comparison. We were saying if this person is this, then what is this person? But more importantly, we were experimenting using expressions. We were actually substituting numbers in and seeing what happens. So that concludes Module 4, Lesson 19. If you have any questions, make sure you get with your teacher and make sure you complete the problem set.